Hello everyone, welcome to attend our class. Today we are going to study section 6.4, Design Method of butt welds in China. In section 6.4.1, we will discuss whether the butt weld needs to be calculated. In section 6.4.2, we will further study the calculation methods of butt welds applied in China. Since the penetration butt weld has become a part of the welding section, the stress distribution on the calculated section of the weld is basically the same as that of the original welding piece. So the calculation method of butt weld is the same as the strength calculation of the component. Only the strength design value of the weld is adopted. According to the steel structure code in China, end taps should be used for important structure, and when the weld quality satisfies the grade 1 and grade 2 requirements, it is not necessary to calculate the bearing capacity of butt weld. When calculating the tensile strength of grade 3 butt weld, the design value of tensile strength takes 85% of that of the base material. When no end taps are used in butt weld, the bearing capacity of weld still needs to be checked, even though the weld quality satisfying the quality requirement of grade 1 and grade 2. For all grade 3 welds, whether or not end taps are used, the bearing capacity must be checked. And axial force, the stress of butt weld is equal to the ratio of axial force to the effective area of weld. The effective area of the weld is equal to the product of the effective length of the weld and the thickness of the weld. The design values of the tensile and compression strengths of welds have been listed in the Standard for Design of Steel Structures, GB 50017-2017 in China. For plate butt welds and the action of moment and shear simultaneously, according to the knowledge of material mechanics, the normal stress graph is a triangle and the shear stress graph is a parabolic. The maximum normal stress on the weld is located at the two ends of the butt weld, which must be smaller than the design value or tensile strength of weld. The maximum shear stress is located in the midpoint of the weld, which must be smaller than the design value of the shear strength of weld. For the butt weld of I section and the action of moment and shear, the maximum normal stress of the weld is located at the upper surface of the top flange of the section and the lower surface of the bottom flange. The maximum shear stress is located at the midpoint of the web. The maximum normal stress must be less than the designed value or tensile strength of weld, and the maximum shear stress of weld must be less than the design value of the shear strength of weld. And the intersection of the top flange and web, the intersection of the bottom flange and the web, where both the normal stress and the shear stress are big. According to the fourth strength theory of material mechanics, the reduced stress must be less than the design value or tensile strength of weld. That is all for this lesson. See you next time.